So we have been talking about sampling and surveying. Now we're going to shift our focus to experiments. But before we do, I want to make sure we know the difference between an observational study and an experiment. What do you guys think the difference is between an observational study and an experiment?
Yeah, observational study, you're not doing anything, you're just watching.
Yeah, an observational study, we're not doing anything, we're just watching. We're collecting data, we're not doing anything. It's like the creepy man at the park watching the kids. He's not doing anything, he's just watching. Nothing weird. But the moment that he comes off that bench and starts talking to children, he's now not observing anymore. So, observational study, we are just collecting data, not interacting with anyone. Experiment, a treatment is imposed. If you look at your vocabulary sheet here, you'll see observational study is a statistical study where treatments are not imposed. Experiment, that's at the bottom of the page, it says that a treatment is imposed. So, observational study, we are only collecting data, no treatment imposed, but in an experiment, treatments are assigned. Now, what are treatments? Treatment is any kind of an involvement, okay? So, for example, I need everybody to raise your right hand.
I was writing with that.
All right, put it down. Was that an observational study or an experiment?
No, that was no, it was both.
Bro, I'm telling you, this is just a guess.
I just cracked.
This was an experiment. I imposed a treatment by asking you to do something. Treatment does not, like everybody always thinks that treatment has to be something like done to you or some drug that you're given or whatever. It doesn't. It can literally just be an instruction. Now, if I just stood here and watched you guys, I'd be the creepy dude at the park, okay? Yes. Yes. All right, so observational study, I'm just collecting data, no treatment, no interaction. Experiment, there is some kind of interaction or treatment, even something simple like asking you to do something, okay? All right, now, before we go on to our experiments, which is the biggest part of this, I do want to tell you there are two different kinds of observational studies. There's a prospective observational study and a retrospective observational study. Prospective observational study means I'm going to select the individuals now and collect future data. Okay, so prospective observational study, I'm going to select individuals now and collect future data. Retrospective, you guys know what retro means?
Old.
It means old, right? Retro is old. So that's going to be past data. So I will select, I will select people now, but collect data from the past.
Dude, two guys in that situation, bro. They would have been
Select individuals and collect past data. All right, guys, here's an example. I'm going to randomly select 5 of you, and I'm going to ask you where you went to middle school. What is that, retrospective or prospective? Retrospective. You guys already went to middle school. That's in the past. I'm going to randomly select 5 of you, and in 5 years, I'm going to call you up and ask you how college is going. That's prospective. I'm selecting you now, but I'm going to get your data later. Does that make sense?
Yeah.
Awesome. So, guys, we have now talked about all the vocabulary on the first page, front and back. Yes, we're rocking and rolling. Oh, my goodness. Look at this example, you guys. So many words. and I know what you want to do. You just want to jump down to the question, the actual questions. But I'm going to caution you, I would definitely read the questions, okay? So here we go. Last year, 30 AP Statistics students at Boyd were randomly selected to take an after-school SAT math prep class with the goal of improving their SAT math score. 10 students took the class online, 10 students took the class with an instructor, and 10 students only had a study book. At the same time, 30 other AP Statistics students were randomly selected to take an after-school number sense class with the goal of improving their SAT math scores as well. Similar to the first group, 10 students took the class online, 10 students took the class with an instructor, and 10 students had only a study book. The group of students who took the SAT math prep class had a significantly higher average on their SAT math score than those students who took the number theory class. Does everybody understand how it worked? I basically took 60 students. 30 of them took number sense, 30 of them took the SAT math prep. Within those groups, I have 3 different instruction methods: online, with an actual instructor, and a study book. Is this an example of an observational study or an experiment? Why is this an experiment?
You're telling them to take the class.
This is an experiment. There was a treatment, and that treatment was the class was imposed. A treatment was imposed. So this was an experiment. Now, in any experiment, we're going to have a response variable, which is going to measure the outcome or the response of the study. The explanatory variable is going to help explain or predict the response or what is happening in the study. What are the variables in this experiment?
The student.
What is the response variable? What is the response? What outcome am I measuring at the end?
I forgot what the question is.
The SAT math score. All right, what about the explanatory variable? What am I trying to see if it is influencing their SAT math score? What am I testing to see if it's making a difference? Yeah, the class, right? The class. So, if you look here, you can kind of tell that the treatment is usually your explanatory variable. I'm trying to see if this explanatory variable is making a difference. The treatment, is it making a difference? Okay? All right. Part C. Part C says, what other variables could affect the student's SAT math score? So not taking into consideration the class or the method that they're getting their instruction. What other variables in the world could affect a student's SAT math score? Okay, maybe their income. Tell me more about that, Danny.
But causation
Depends on where the different because their parents could give them tutoring.
Very good. Maybe they've had previous tutoring or not. Good. What was one you said?
I should say they care.
Yeah, their motivation. Very good. Their motivation. What else? What else could influence your SAT math score?
If they've taken pre-calculus or algebra.
Their other math classes. Other math classes. McKenna?
How much sleep they got.
Yes, how much sleep they got the night before they took the SAT. What else? What'd you say? Oh, okay. Maybe they're extracurricular. Maybe if they're busy or not. Right?
Like if they ate a good breakfast that morning.
Very good. Whether they ate breakfast that morning or not.
If they're smart or dumb.
Their natural intelligence.
IQ.
Yeah, their IQ. Yeah, basically. So guys, look, there's tons of other things that is influencing the result of our data that we didn't even take into account. Those have a very specific type of name, or those variables have a very certain, or a very specific name for them. There we go. Those variables have a specific name for them. They are called confounding. Confounding variables. Everybody say the word confounding.
Confounding.
That is probably a word you have never said before in your life, okay? Confounding variables. It's kind of like variables that are confusing the results. They are confounding the results, okay? I'm not taking into consideration those things whenever I'm assigning people to which class they take. I'm not taking into consideration if they got sleep or not. I'm not looking at that. Those are confounding variables. They can mess up our data. Yeah. All right. Experimental units. If you guys look at your definitions, an experimental unit is the object to which a treatment is randomly assigned. So, who or what are the experimental units in this example? Yeah, it's the 60 AP Stats students. Because again, the example told us that we selected 30 AP Stat students, put them in one class, 30 more AP Stat students, put them in another class. So my experimental units, the people that are getting the treatment are the students. All right. Here's probably the most confusing part. Here's probably the most confusing part. Factors and levels. Factors.
Factors is multiplication.
If you guys look at your vocabulary, it says factors. In some experiments, there are multiple explanatory variables or factors. So, guess what? In this experiment, there was actually 2 factors. One of them was the class. Okay? That was our explanatory variable that we identified already, but there's actually a second explanatory variable. Within each class, students were then assigned to do something else, and it was what kind of instruction they got. So we have 2 factors here. We have the class, and we have the instruction type. Okay, those are the factors in this example. The class and the instruction type. Now, each factor has a number of levels, and it's basically just what options were there. So for class, how many options were there? There were 2 options. So there were 2 levels. It was the SAT Math Prep class and the Number Sense class. So for class, there were 2 levels. Class was the factor, but there were 2 levels for that factor. Now, with the instruction type, how many levels were there? 3. So there are 3 levels for instruction type. And what were they?
So levels are like
Levels are like options. How many options are there? Yep.
yeah.
And what were they?
Oh, yeah.
Online, instructor, and study book. So I have 2 levels for my class, for my factor of class. I have 3 levels for my factor of instruction type. Now, the fun part. You remember how I told you there's no math in this unit? We're about to do math.
No. What? No.
Why would you lie to us?
And there's numbers up there.
It's gonna be okay though, you guys.
She knows how to
You
manipulate
won't
those
even need any calculators.
You know
How do you determine the number of treatments in an experiment? You multiply
You said no math.
Multiply.
the number of levels with each other. Now, if there's only one factor with a few levels, so let's say it was just class, then there would only be 2 treatments. Okay?
I understand.
But because I put people into class and then I break them into 3 different groups each, now how many treatments are there? There's 2 classes times 3 instruction types. And again, I apologize that there's math, but here it is. How many different levels are there? I'm sorry, how many different treatments are there? 6 treatments. So 3 times 2. Here's what that means. That means that any one of the 60 students could get put into one of 6 different pathways for this experiment. They might get the number sense class online, or the number sense class with an instructor, or the number sense class with the study book, or the SAT math prep class with the instructor, SAT math prep class with the study book, or SAT math prep class online. 6 treatments that are possible. Does that make sense?
Yes.
That's not that bad, is it?
But that's the boundary.
Nope.
That's it?
That's where we draw the
You
line.
can't be making us do no
We
more
draw that
numbers
line.
than
We're
that.
drawing the line right now.
That's it for the math, I promise.
You promise?
I promise.
You have deceived us before.
Promise.
Nikki.
All right, you
Statistically
guys.
speaking, it is not.
Your Z schools, not so much.
So, we have talked about a lot of different vocabulary words, but for the most part, this is fairly straightforward. It's just putting vocabulary words onto what you probably could have figured out on your own. All right? But now we're going to talk about something that's a little bit specific to statistics. It is the 4 principles of experimental design. Number 1, comparison. Here's what comparison is used for. I must have more than one group in order to see if the treatment actually caused a response or not. So I recently heard about this new candy that I could give to students on test day. And if you ate this candy or sucked on this candy while you were taking the test, you would have a higher test grade. So what I'm thinking about doing is bringing that candy next week when you have your test and giving it to every one of you. Is that a good idea?
Yes.
Well, what if you all do better on the test? Am I for sure that it's because of the candy?
Causation now means correlation.
What could it be? Maybe you actually studied for the first time this year. Maybe this unit's just easier. Maybe the test was just easier. Maybe I graded nicer.
Maybe we all cheated.
Maybe you all cheated. You figured out how to cheat. Right? So, like, if I just give the candy to every one of you, how do I know if it was the candy or if it was something else? I don't. So, I need to have comparison. So, how could I fix this so that I have some comparison?
Do it multiple times.
What do you mean?
Like in different periods. In different.
Same test.
Oh, okay, let's think about that. Can I give like first period gets candy but second period doesn't? You guys get candy but seventh period doesn't? Can I do that?
I'm fine by that.
You could, but
Could I do that?
Why not?
What's wrong with doing it that way?
different people.
Different class makeup.
Oh God.
The way that you guys interact when we're taking notes is very different than my 5th period, who I struggle to get notes through with them. So that would be a very different situation. So, and you guys, there's 33 of you. My next class, there's only 15 students. So we usually can talk a little bit more about what we're doing than you guys are able to because there's just less of them. So is it fair to do it that way? Probably not. So what should I do?
Take away each treatment.
I think that we should probably do half of you are going to get the candy and half of you are not.
I'll take the
So
candy.
this like that's an awful idea.
Now, here's the deal. How do I decide who gets the candy? Should I pick the top 10 students in the class get the candy?
Random number generator.
Random assignment. That is our next experimental design quality.
It should be the kids that are the dumbest of the class. So if they do good,
Yeah, it's true. Give it to the dumb kids.
you'll know.
Now, why do we do random assignment?
Because you hate the dumb kids.
Like that one kid who got the 50 on that test.
Here is why we do random assignment, you guys. It is to create roughly equivalent groups by balancing the effects of other variables. Here's what I mean. If I do random assignment, then I am probably going to get a little bit of the super smart kids in each group. A little bit of each group will have some of the kids who studied. Each group will probably have some kids who, I don't know, didn't eat breakfast. Each group will probably have some of the students who don't take very detailed notes. Maybe each group will have some of the students that are distracted by being on their phone during class. Maybe, right? Maybe each group, because of random assignment, will have a little bit of each student that has like different IQ levels. So things like that. So hopefully I'm balancing that by doing random assignment.
But it could also randomly get one group.
Can random assignment be bad?
Yes.
Sometimes. I might randomly get all of the really distracted students in one
You
group.
want the smartest thing then? If you know your class, just to be the people people from each type of makeup.
But then I'm biasing the results.
Yeah, but like you
Or
have
you
to
just
be
put them all
unbiased.
to me and see how I do. 'cause we don't
Now,
have this.
I could just do this. I could just randomly pick one kid and give that one kid the candy. Would that be a good idea?
No.
Why not?
Why we like so dumb super smart, bro?
That is called replication.
Just find your most average, run-of-the-mill student.
So,
and give them the game.
in science, replication means to do the experiment more than one time. In statistics, replication means to make sure you have more than one subject in each of the...
Who just took a picture?
Bro, no, I don't
That is
consent.
odd.
There was no consent to that. Can I go jump
That
on
is.
this?
that
in
is
each
odd.
of the groups, okay? Now,
you're
this
weird.
is what it's for.
Kid's weird. Look at
Get these weirdos.
This ensures the results are not due to chance. If I only give the candy to one person, what if by chance they did a really good job of guessing on that test? It had nothing to do with the candy, but chance allowed them to show that they did better on the test than normal. Well, that's not a good deal. So I need to make sure that it's more than one subject that gets the treatment. The last one is control. This goes back to why do I not do this per class period? I want to control the fact that each class period has a different style of learning. I'll go with that. Basically, I want to make sure I'm taking out the confounding variables that I can take out, which would be how you guys pay attention, the class makeup, that kind of thing. Okay? All right, so what are the 4 principles of experimental design?
Rubbers.
Wow.
You push it when you get it.
What are the 4 principles of experimental design?
First, random, replication, draw.
Sofa.
I'm so sorry that this does not have a fun acronym.
It's literally
It
just.
just is. It's crack. All right. Alrighty. Okay. Nice. All right. Let's talk about multitasking.
Son of a.
Some of you guys think you're good at multitasking. I'm here to tell you you're not.
Oh, my teacher said.
Researchers in Canada performed an experiment with university students to examine the effects of in-class laptop use on student learning. All participants in the study were asked to attend a university-style lecture and to take notes with their laptops. Half of the participants were assigned to complete other non-lecture-related online tasks during the lecture. These tasks were meant to imitate typical student web browsing during classes. The remaining students simply took notes with their laptops. To assign the treatments, the researchers printed 40 papers with instructions, 20 with multitasking, 20 without, shuffled them, and handed them out at random to students in the classroom. At the end of the lecture, all participants took a comprehension test to measure how much they learned from it. The results? Students who were assigned to multitask did significantly worse, 11% worse, than students who were not assigned to multitask.
Is this accurate?
Yes.
Oh.
Explain how this experiment used comparison. How did we have comparison here?
We compared the people who was multitasking with the people who were.
Multitask versus
Now, what
non-multitask.
if these kids that they said they was multitasking and they didn't because they're lame?
Maybe.
No one got lost, they're just stupid.
Okay. Explain the purpose of randomly assigning. Ladies and gentlemen, the purpose of randomly assigning is always the same reason. To create
To create.
roughly equivalent groups.
To create.
By balancing the effects of other variables. To create roughly equivalent groups by balancing the effects of other variables. That is always the purpose of random assignment. Hopefully, by doing random assignment, I have a little bit of good multitaskers in both groups. I have a little bit of bad multitaskers in both groups. I have a little bit of ADHD kids in each group. I have a little bit of non-ADHD kids in each group. I have a little bit of people who didn't get sleep in each group. I have a little bit of people who are technologically savvy in each group. So again, I'm balancing all this stuff by randomly assigning it, okay? I'm not just taking my top kids and putting them in the multitask group.
Say who? Scripture.
All right? Explain how the experiment used replication.
It's picking a certain person.
Replication is making sure we have more than one in each group. So how did we use replication?
We just.
Oh no, I do the work.
There are 20 in each group. Now, what is the purpose of replication?
You like an even results from each group.
Purpose is to ensure results are not due to chance. I want to make sure that I don't just accidentally pick the one kid in class who is just a really great multitasker. Or I want to make sure that I don't just accidentally pick the one kid in class who is just, I don't know, had no sleep last night and falls asleep halfway through the lecture. So I'm taking out the chance by making sure that I've got 20 kids. So if one kid falls asleep, I've got 19 others that are still doing what they need to do.
That
Okay?
would be me as well. See me.
All right, last question here.
I'll be driving, texting, drinking.
Name 2 variables that were controlled in this experiment. Now, guys, there's way more than 2, but give me 2, or give me a list of things that were controlled.
40.
Say that again.
I didn't listen, so I'm just like getting from things. It says I see 40 papers.
For the students one, they were 12
I just started off.
Huh?
The students,
Yeah, how did we control in this
the
experiment?
they either had multitask
I
or
say
not.
everything else.
What do you,
You had
what are some things that I controlled?
randomly assigned.
Oh,
it's
11%.
40 papers?
That's already said.
No, we just got that wrong.
Basically, when you're controlling things, you're trying to keep things the same between the 2 different groups. So what are some things that are the same between the 2 different groups? There we go. They all had the same lecture.
Oh, they did.
What else?
Same laptop.
They all were told to take notes on their laptop. Okay? Notes on laptop for everyone. What else?
They had like the same amount of
Same script.
access to the internet.
Okay, good. Very good. They all are in the same space as far as Wi-Fi access goes. Okay?
Same teacher.
Oh, same teacher, same instructor.
Good job, man.
At the end, what did they all do?
Take a test or whatever.
They all took a test, and guess what? They all got the same one.
That's crazy.
Even the multitaskers were asked to multitask with their laptop, not just multitask in any way that you want.
Yeah,
they were asked to multitask with their web browser.
Cheap, bro.
All right, so there's a lot of control here. Why? What is the point of controlling?
To make sure we get the most accurate and thorough.
To limit, what am I trying to limit?
The
Like
change,
skewness,
things,
like inaccurate.
What kind of variables am I trying to limit?
no, what was it called? You literally
Confounding. Everybody say confounding.
confounding.
Wow, that was like two people.
Confounding.
Limit confounding variables. I have a question for you.
What is
Can I have so much control in my experiment that I eliminate all confounding variables?
No.
Never. I can never do that. I'm just trying to limit as much as I can. Okay? Do you guys have any questions? Oh, wait. I have a question.
Yes.
What are the 4 components of experimental design?
Random assignment, application,
Okay? Good, good, good.